practicing architect in Amritsar. Over to you, sir. We have architect Guneet Khurana. Sir. Architect Guneet Khurana.
Audible?
Gigi, yes, sir, you are now
Hello?
audible.
Yeah.
Yes, sir,
Right.
you're audible now.
Hi. Good morning. My name is Architect Meet Singh Khurana. Today's webinar is organized by Punjab Energy Development Agency with the support of Bureau of Energy Efficiency, BEE, New Delhi. We welcome all the officers and staff of PEDA and BEE. Special welcome to the Chief Executive Officer, Mr. NPS Randhawa, sir, Mr. MP Singh, Director, Mr. Paramjit Singh, Senior Manager, and Engineer Manipanna. Special welcome goes to all the departments and staff of Punjab Mandi Board, Punjab Health Systems Corporation, Department of Health and Family Welfare, Department of Science, Technology and Environment, Department of Tourism and Cultural Affairs, Punjab State Council of Science and Technology for their participation in these webinar and other professionals. Dr. Arti Grover, School of Planning and Architecture, New Delhi, will be giving introductory address in the beginning and concluding remarks at the end of the webinar. We welcome our speakers, energy expert, Mr. Kangaraj Ganesa, architect Surinder Baga, architect Glory, engineer Vivek Mahajan. We highly appreciate them as they have spared their valuable time to spare
Architect Guneet Khurana, I think your voice is not audible. Kindly check your internet connection, please. Architect Guneet Khurana.
Ramnik, you can proceed further.
Okay, sir. So thank you very much, Architect Guneet Khurana, for introducing our esteemed guests today. And now I invite Dr. Aarti Grover from SPA New Delhi for her inaugural address. And I would also like to request her to introduce to the theme of our webinar. Dr. Aarti Grover is an associate professor in the postgraduate course of landscape architecture at School of Planning and Architecture, SPA Delhi. With a professional experience of more than 18 years, she has worked on projects of various natures and scales related to landscape architecture, habitat design, architecture, and interior designs in various capacities. Her name is associated with some very prestigious projects in the country like Rashtrapati Bhavan, New Delhi, Sea Hexagon, ONGC, Interactive Outdoor Plaza at IIT Kanpur, which is ongoing, and rejuvenation of water bodies in Delhi cantonment area. She's also has been working and writing exclusively on architecture education in India. Over to you, ma'am. We have architect Aarti Grover.
We have to wait for a minute because Aarti is just joining. There's some technical problem. Just 1 minute.
Ji. So today's event, I would again extend my warm welcome to the members of various institutions from Punjab Mandi Board, Punjab Health System Corporation, Department of Health and Family Welfare, Department of Science, Technology, Environment, Department of Tourism, Cultural Affairs, Punjab State Council of Science and Technology. And I request my audience, there will be a link for the feedback form. As this is our last 7th day of a webinar, you are requested to please kindly fill the feedback form, which has just 10 to 12 questions in a yes or no format, and it has hardly gonna take 5 to 7 minutes. So these questions will actually help us a lot in the future webinars. So I request the audience to kindly fill the feedback form. We will have architect Aarti Grover with us soon.
Yeah, I'm here, Ramni. Thank you.
Yes, good afternoon, ma'am. How are you?
Yeah, I'm good. I'm good.
Gee, so now we have architect Aarti Grover. Over to you, ma'am.
Hello, good afternoon, one and all present here today. Am I audible, Ramni?
Yes, ma'am, you are. Yes, you are.
Okay, I am Dr. Aarti Grover, member faculty Landscape Architecture, SPA Delhi. And I will start by congratulating PEDA and Sakar Foundation for generating this unique platform in the form of Energy Conservation Week to echo voices and views on topics of conservation, sustainability, and livability. One is delighted to express the absolute pleasure to be a part of such an extremely relevant and scholarly discourse on the most important concerns of contemporary times. The term energy efficiency has been quite rhetorically used in all our discussions, but the greater question is whether or and to what extent are we really translating it onto ground in a manner which is impactful and result oriented. There were times when natural resources were in plenty and the humans had all that liberty to enjoy these resources to as much extent they wanted to. But with increasing demands and the increasing statistical counts, I must tell you that the level of urbanization has also increased so much that we are witnessing a completely changed paradigm in this regard. So this epistemological shift that we are seeing today is critical to understand and bring to application as fast as possible. Otherwise, what I really feel is that we, in all our ignorance, are creating unimaginable lives for our future generations, which are yet to come. Sustainable means of energy production, utilization, and recycling become imperative in the given conditions. Reducing the energy demands and shifting quickly to green technologies and products is the mantra, which will ensure sustainable living, sustainable solutions to the highly dynamic and oscillating association of human life and energy. That specialization of designing the human habitat that we belong to calls for rather an aggressive approach in this area. Employing methods and processes to optimize the designing cost, operational cost, and maintenance costs while fulfilling the demands and aspirations of the users and stakeholders is definitely very complex and a very humongous task. Yet there are solutions which need to be adopted for a better way of life. Responsible use of resources is primary, of course, that we all know, but greater good lies in disseminating and capacity building, which exactly is the cause we are all here today. To share their views and technical knowledge in the domain, we have some really sought after professionals who I am really proud to introduce to the August gathering in the room. We have with us architect Kanagraj Ganesan, architect Glory, architect Surinder Bagaji, who of course is a stalwart in the area, and engineer Vivek Mahajan to talk about various aspects of energy conservation. So without any more ado, let me take you through a knowledge-filled journey of about an hour, refreshing and learning the nuances of sustainable living. Wish you all an enlightening and fulfilling session ahead. Over to architect Ganesan, an ECBC expert who will deliberate on building envelope. Thank you.
Thank you so much, ma'am, for the introduction of today's seminar of our esteemed speakers and brief of our today's upcoming talks. So moving to our first session on building envelope, I would like to invite our first speaker, architect Kanagraj Ganesan, to give his presentation. He is currently director of Integrative Design Solutions Private Limited, Delhi, and also provides technical support to Energy Conservation Building Code ECBC cells in 12 states and 5 union territories. The objectives of the ECBC cells are to assist states and UBs in implementing ECBC through government notification. And he's also part of the core team, which developed design guidelines for energy efficient multi-story residential buildings for 3 climatic regions of India. He's also involved in the implementation of net zero energy retrofitting of United Nation House in Delhi. So we have architect Kanakraj Ganeshan with us. Sir, over to you.
Thank you. Just want to check whether I'm audible and my screen.
Yes, sir. Yes, sir. You audible and screen is visible too.
Great. Thank you. So first, I would like to thank PEDA, Bureau of Energy Efficiency, and Sakar Foundation for giving me this opportunity. And I hope all of you are doing good and staying safe. So today I'm going to talk about energy efficient building envelope. And I will be taking you through a high level overview, like how we can go about designing the building envelope. So if we look at India, India has 5 climatic zones, and around 80 to 85% of the geographical area, we have warm or hot summers. So maybe we need to provide cooling to get the thermal comfort in most part of the country. When we talk about envelope, we basically revisit our 8th and 9th class physics. So there are 3 modes of heat transfer. All of us know: conduction, convection, and radiation. And when we are trying to look at envelope, envelope is any surface which basically distinguishes the internal environment from the harsh external environment. It can be your roof, wall, windows, or the floor. And we need to really understand like how we can reduce the amount of heat which comes from outside to inside. So heat always moves from hotter side to the colder side. So if you look at this diagram, it shows that the thick arrows basically shows the conduction which happens through the opaque surfaces like wall, roof, and also the transparent surfaces like windows. And the other arrow, which is number 1, it shows the radiation which comes in from the windows, because it is a transparent or a translucent component. So we need to see that how we can reduce this heat which is coming from direct solar radiation. Apart from that, the windows are also used for providing ventilation. And there are also situations where the pressure at the windows are not sufficient. Then we might need to do some kind of a mechanical ventilation to exhaust the air. So this is how an envelope basically contributes. And our main objective is, like, whenever the temperature outside is even 40 or more degrees Celsius, we need to still maintain 22 to 24 degrees Celsius inside the room. So it is very important for us to ensure that less heat comes inside the space, so that we get better comfort inside the room, and as well as less energy consumption for space conditioning equipment. So 3 principles which I'm going to talk about today, you can call it as mantra. In these climates, you have to insulate the building well, you have to ventilate the building well, and you have to shade the building well. So if we look at the building envelope without insulation, we can see that a lot of heat actually comes through conduction and also through radiation in these things. So it is very important that whatever is the component which distinguish the outside environment from inside environment, we insulate it well. So by insulating, we can have a better thermal comfort inside the space, as well as lower energy consumption for our space conditioning equipment. So how do we insulate? So for wall, we can have cavity walls where the cavity itself can act as an insulation. And also there are different material like expanded polystyrene, extruded polystyrene, or various, I would say, like glass wool and rock wool kind of insulation. You can use it to improve the thermal performance of the wall. Second thing which is important to understand is in the roof, we can see that roof basically gets a lot of solar incidence, around 3 to 4 times more than the wall. So it is very important for us to provide treatment to the roof. And this can be in the form of underdeck insulation, which you can put below the slab of the building, and or you can also provide it on the overdeck, which is on top of the slab. The overdeck is better because we understood that the heat moves from hotter side to colder side. So the more you put it on the external surfaces, the insulation would be performing better. Another thing which you need to ensure is roof finishes should be either white, green or blue. So white is like what we have in our traditional times, like we used to do lime plaster or lime wash. So similar to that, we now have tiles as well as paints, which reflect a lot of radiation which falls on the roof surface. Or you can have a green roof, or you can have photovoltaic or solar thermal on your roof, which further shades the roof below. So we need to ensure that the roof should not be exposed and should have at least one of these treatment as a surface finish. Energy Conservation Building Code mentions the conductance value for the roof and the wall assembly for different climatic zones of the country and for different types of buildings. So I will not go into the detail of it, but the lower the conductance of the material, wall or roof, the better it is for the tropical climate. The third component of the building envelope where we need to pay attention is the windows. And the windows usually constitutes of glass as well as the frame. So we need to ensure that we use a good double glass, which reduce the conduction of heat gain from the glaze part of the window. And we need to also have some kind of a film which does not allow the solar radiation to come in. So this can be obtained by using double glazing and also using frames which are either wooden frames or UPVC frames, or if you are using aluminium, then you have to have a thermally broken frames. So when we look at double glazing, it is almost similar to the flask we have. Some of you would have seen a broken flask, and inside that you would have seen a silver lining. So these flasks can be two types. Either it can store the hot item inside and it does not get cooled, or it can also store the cold item inside. So whenever we go to buy a flask, we generally ask what kind of flask we want. So it all depends upon where that coating, silver coating is. So if the silver coating is at the inside part of it and the next thing around it is a vacuum, so the hot thing will remain hot inside. So this is the same situation with the window. If we are considering a colder climate where outside is cold and inside is hot, then you need to provide a film in the inner layer of the inside glass. But in the hotter climate, it should be on the outside is hot and inside is cold. So we know that heat flows from a hotter to colder side. So we provide a film in the third layer of the outside glass. So that is more about insulating the building. The second thing is looking at ventilating the building. So ventilating the building also is a very simple concept. We know that hot air tends to rise up. So we need to provide openings so that the hot air can go out, and this is called stack effect. So you need to design your openings in a manner that you provide cold air from the bottom and then basically the hot air goes up. But there are situations where the outside air is not sufficient to provide ventilation. So during those times, you need to have some kind of a mechanical system to ventilate it. So these are the three modes of ventilation. One, you can have natural ventilation or a cross ventilation, where the air comes from the window and whenever the outside temperatures are better, you ventilate your building. The second one is to use an exhaust fan. And the third one is to have both, like we call it as a mixed mode operation of the building, where you can run the building on an air conditioner mode whenever outside is not conducive. And whenever the outside is comfortable, at that time you try to bring the good part of the air inside and provide thermal comfort. This is very important in today's context, especially when we are facing this pandemic, where most of the buildings which do not have openable windows are facing challenge for the fresh air. So it is very important in the future building that we basically develop them as a mixed mode operation buildings. Another thing is you need to provide taller windows. So the taller windows have a good heat rejection possibility where cool air can come from inside and warm air can go from outside. So whenever you are designing a window, ensure that a part of the window which you are going to use for ventilation purpose, you try to put it as a longer aspect ratio window. Then we need to ensure that we shade well. So after insulating and after ventilating, we need to also ensure that we shade well. And in India, like you will see that in the summer times, we have a high altitude sun. And during the winter time, we have a low altitude sun. So sun rises from the east, moves towards the south and goes towards the west. And only in the southern part, as you go below the Tropic of Cancer, you will find that the sun also comes on the northern facade. So there you have to shade the northern facade also. So our main objective of the shading is to not to cut the summer sun, but allow the winter sun to come in. So the shading, you can do it through the following means. You can have mutual shading. So whenever you are trying to place another building, like a residential tower next to the first tower, it would be useful if you can provide this tower on the east or west compared to the north side, so that we can take the advantage of mutual shading. So this is the slide which shows that if you put buildings next to east and west side, you get a better mutual shading impact. The second thing is to look at self-shading. You can have various projections in your building so that the building shades itself, so that again lowering the heat gain through the radiation part. Then the next thing which is quite getting popular is to provide shading outside. So like the way you have a curtain or the Venetian blind inside, it would be much better if you can provide the shading device outside, because once the radiation comes inside, it becomes a part of the cooling load of the building. So we really need to ensure that we cut the sun really outside. So windows are like eyes for the building, and whatever culture we are in, we shade our eyes. So the buildings also starve for eyes, shading systems. So we need to ensure that we design the shading system well, and this is the most critical part because this leads to a lot of heat gain inside the building. Another interesting thing is whenever you shade something, that is the place where a lot of radiation actually falls. So automatically they become a good place where you can put photovoltaic for shading, for getting the electricity generation. So one can also integrate them. A few more technologies which we need to look at from the envelope point of view. These are like building integrated photovoltaic, external movable shading system, which I talked about. Now it is also getting very popular to use phase change materials. There are these electrochromic glass, which when the radiations are good outside, they become transparent, and as soon as like the radiation start falling on the windows, they basically switch their properties. And similar to the cool roof, we now are also talking about cool walls. Now I am coming to the last part of my slide. So it is not always that you do one strategy at a time. While designing the envelope, you can see in this case that you need to have a good glazing outside. Then you have inside also a good glazing so that the conduction is reduced. Then you also have something like an external movable shading system which can be retracted when the ambient conditions are good and brought back when they are not that good. And because the temperature between these two glasses goes up, so you also ventilate these facade. So one has to really see the integrated design process, like how we put together the envelope solutions to cater to the climate. With this, I come to the conclusion of my presentation. So again, I repeat, insulate well, ventilate well, as well as shade well. And that is a simple technique to deploy for the tropical climate. Over to you, Yannick.
Thank you so much, Architect Kanagraj. So, sir gave a very good presentation on building envelope. So, he gave us an overview of different type of insulation that we can definitely adopt in our, buildings. So, and also to keep it cool in form of insulation. Certainly, even ventilation is an essential part of our building working. And Architect Kanagraj explained it really well. Thank you so much, sir. And now for our next presentation. We have Architect Glory with us, and her topic of presentation will be sustainable design concepts. She is founder of buildgreen.design in Gurgaon, team leader of PricewaterhouseCoopers Private Limited in Gurgaon, implementing ECBCR ENS in the state of Uttar Pradesh, having more than 17 years of success in managing large-scale commercial, mixed-use, and residential projects. She is adept in incorporating sustainable features into designs and developed efficient build space. We have Architect Glory with us. Over to you, ma'am.
Yeah, I'm sharing my screen. Thank you very much. Is my screen visible?
Yes, ma'am, your screen is visible.
And what do you see right now?
We have a first slide, sustainable design concepts, a step to reduce carbon footprint. We see the first slide, ma'am.
Okay. So is it in the, right now it's the same thing that you're seeing, or is it changed?
No, the same slide.
So that's what you see, right?
G. Try using the keyboard. Maybe the slide will change when you use the up and down button on the keyboard.
Okay. So a very good afternoon, all of you. My video is also on, or is it off? Yeah.
Yes, we can see you, ma'am.
Yeah. Thanks. A very good afternoon. PEDA along with PEE has organized the Energy Conservation Week, and during this week-long session, we have seen the entire measures that our nation has adopted, our world is adopting towards the energy conservation measures. And definitely I'm thankful to Sakar Foundation who have invited me for sharing the thoughts on what exactly sustainable architecture, sustainable design really means. We have seen our parents, grandparents, they usually say that हमारी अब आजकल बहुत गर्मी हो गई है, पहले इतनी गर्मी नहीं होती थी. So why is it? What is it exactly? It is all about the climate change, but is climate change really the emotional part? Is it driven by emotions? Not really. Climate is a very complex term. It uses lots of data points, and it is the average of all the data points for over 30 years. And that is called the climate set. And if there is a change in the pattern, that is called the climate change that we are talking about throughout. There are lots of protocols that have been developed for this climate change, and it is all backed by science and statistics. We have seen one of this Kyoto Protocol is one of them. Like India is a party to the United Nations framework Convention of Climate Change, UNFCCC, and the objective of convention is to achieve stabilization of greenhouse gas concentration in the atmosphere at a level that would prevent the dangerous interference of the climate system. To strengthen the developed country commitments under the convention, the parties adopted Kyoto Protocol in 1997, which commits the developed country parties to commit to have the carbon dioxide emission below 5.2% in 1990. So even PEDA is designated as the nodal agency for carbon credits and clean development mechanism. And it has eligible for projects within the state for the Punjab government. I'll just should talk when we are talking about clean development mechanism, where Punjab State Electricity Board has been one of the pioneers, and the government installed. There is a policy that if the distances, if the transformers are installed, huge transformers are installed, and for a very long distance, there is voltage drop. But when small sized transformers are installed, it reduces the voltage drop and hence the wastage of electricity. That was the concept the Punjab government took up, and almost 17 states, 17 cities, different divisions were catered under this scenario, and almost like 4,500 metric tons of carbon dioxide equivalent has been saved annually, is saved annually. Again, we have another Paris Agreement, which as per the Paris Agreement, the overall global objective of limiting the global temperature, is global temperature rise is no more than 2 degrees centigrade above the pre-industrial levels. However, we need to pursue the efforts to limit the global temperature to 1.5 degrees centigrade. The current annual emission that we see is around 52 gigatons. Yeah, with continued reductions that we are already doing, we see it will reach, if it continues the same way, it will reach around, by 2030, it will reach around 52 gigahertz of carbon dioxide. Even during the COVID times, if you can guess, what was the emission reduction, carbon dioxide emission reduction, if you can guess, it was hardly 5 to 7% of the total of, even after so much of disruption in the growth in the economy, and there has been only 5% to 7% reduction in the carbon emission. So that brings us to the point that we need to have a larger picture to work on, develop new technologies to get into this range, 25 to 30 range, so that we can have this, we can reach the 1.5 degrees target. And by the mid of the century, we need to limit it to zero emissions. Only then our nation, our world is going to combat with the climate change. If at all we do not take any corrective measures by 2100, what we see, it's almost 4 to 6 degrees rise in the temperature. And if we do take up some measures, then here, this is what we usually, that we see or almost up to 2 degrees. Now, just if you can tell me, maybe in the chat box, if you can put up, what was the average temperature during the Ice Age? Right now, the Earth's average temperature is around 15 degrees centigrade, right? And during the Ice Age, what was the temperature? The Earth's average temperature. it was around 9 to 11 degrees. So you can very well imagine that from ice age to the present scenario, the temperature range has been just 4 to 6 degrees. And by 2017, we have already reached the 1 degree increase in the climate. So the entire environmental balance would go for a toss if this situation is not taken in urgent needs, taken up in urgency. So how do we do that? The reducing of the carbon footprint. The entire week has been a very enlightening week for all the participants. What measures can be taken up? Even Mr. Kanakraj just now, he has explained very well what all measures can be taken up. Those are the primary measures. So first of all is we need to start early. We need to evaluate and measure the building's design carbon footprint as early as possible. And that is when the most of the opportunities for the reduction is possible. At the early stage only, we can opt for alternative layouts, materials, which can be considered, and details that can be refined to use less of the material. As the design progresses, these opportunities start diminishing. Part of this early planning involves life cycle assessment, on which carbon footprint is based. It is a process of considering all the flows, the energy, the water, the material, the waste in and out of the system, and to calculate the environmental impact. The orientation, this is the basic. The passive design basically depends a lot on the building orientation. Orienting the building to such a way that it takes the maximum advantage of the sun moving across the sky, to use the orientation in the best possible way is the ideal way to take it up. Just now, Kanakraji just explained how overhangs, the exterior shades, they can help out in orienting and using the entire sun's energy. So unless all these factors are considered, the overhangs, the exterior shades, even the trees that can help in the summer sun to keep the thermal mass out inside the building, we have to keep the building heat intact. We have the walls, the entire envelope to keep the entire heat and to stop the flow of the heat from outside to inside, from inside to outside. So this is one of the ways. Then lighting plays a very important role. Sorry. The climate in which a building is located may dictate the type of windows that are needed. In hot climates, the goal is to keep the heat out of the building. So the windows may have low E coatings, and then some of the windows may be designed with lower SHGC. Some of the faces of the building are more prone to heat, and some of the faces are not that prone. So the entire building can be optimized accordingly. We can optimize the daylighting as well as the artificial lighting. Use the state-of-the-art artificial lighting system, because lighting accounts for almost 40% of the energy used. So the thermal gain lowers the carbon footprint, but too much of thermal gain in summer causes overheating and increases the need for the cooling too. So the solar control window films are also available, which can reduce the carbon footprint by cutting down the energy expenditures by up to almost 30%. Then of course, natural ventilation plays a very important role. It's very effective where the climate has ambient air temperature that can be used. So maximum advantage should be taken up for using up the ventilation. Then HVAC definitely plays a very important role. It takes up almost like 40 to 50% of the carbon emission. So the most efficient HVAC systems should be adopted, and that would help in maintaining the carbon footprint. Water usage, the major factor contributing to the carbon footprint of the building is the amount of energy expended to supply, treat, and use the water. The water-oriented strategies significantly reduce the energy use and the greenhouse emissions. Designing for water conservation, then efficiency, and reuse are one of the largest and most cost-effective and carbon reduction strategies that are available. Then use of rainwater as the valuable water resource, design of buildings to harvest the rainfall, create outdoor spaces that rely primarily on the precipitation for irrigation. Then rainwater harvesting and xeriscaping can result in almost 50% of the outdoor water use. Then water for flushing, irrigation, washing machines need not be the potable water. So using the rainwater directly from the building's roof, all these measures, they can help in reducing the carbon footprint. Then recycled content in the materials, materials used in the building, then choosing the recyclable building materials that have less effect on the environment. When we talk about the renewable energy, we have been seeing that the entire building's carbon footprint can be reduced by sourcing its operational energy from the environmentally responsible resources, or by generating the renewable energy on site, using the walls or roof of the building for the photovoltaic system and generating electricity through this system that can impact the entire carbon footprint of the building. Insulation, as Mr. Kanakra just mentioned, there are millions of ways of insulating the building through the material use and through the material that you are already using. Like for instance, we see a single brick thick, 9-inch thick brickwork. This has a U value of 1.78, but a double brick, maybe the same brickwork, which can be arranged maybe there are lots of ways where you can place it in a different manner, like a rat trap. If they are arranged in a rat trap manner, you already have the air gap between the bricks, and you can easily reduce the U factor, and this would help in the insulation. There are many developers, there are many organizations who do not want to move out of the brick concept, not getting involved in the new technologies like adopting AC blocks and all that. So they are getting into ways of experimenting and taking up measures like providing air gaps between the brickwork, and that is one of the way they are opting for the insulation. So these are few of the tips and tricks that that anyone can adopt while constructing the building. So these were few of the measures how we can approach the take view of the carbon footprint. Now, when we look at the environmental aspects, what are the environmental aspects exactly that we are catering to? These can be clubbed under the 5 basic elements like air, water, earth, fire, and space. Fire, which I usually consider it under the energy consumption. Space is the daylight. When we are talking about earth, we are talking about the site, the soil, the vegetation of the material, the construction waste, and the waste which is produced from the buildings when it is already occupied. So all these come within the earth element of the environmental aspect. Next, we have air. We discuss about air quality, the indoor air quality in the buildings. We talk about air pollution, the toxic compounds which are emitted into the air because of the materials that are used in the construction. All that comes under the domain of the air. The next and one of the most important aspect is the water. So we have the quality as well as the quantity of water discussed here, and the wastewater which is produced and treated. So all of that comes under water. And fire, which we talk about the energy consumption and energy generation from, for example, the renewable energy sources of energy. And in space, we're talking about the daylight in the building. So all these aspects are tangible. They can be quantified, they can be calculated, and hence there can be assessment which can be made on these parameters. Now these concepts can be divided under these three main heads. Yeah. All the five environmental concepts, just what we just discussed, the five जो पांच तत्व हैं nature के, they can be divided under these three heads. The green building, which this is the normal practice that we are creating. This is a practice for creating the structures using the processes that are environmentally responsible, resource efficient throughout the building's life cycle, from site to design, construction, operation, maintenance, renovation, and destruction at the end of the life of the building. So here, green buildings mainly focus on the environmental dimensions of the sustainability, and the other dimension, which is the social dimension, takes a little backseat. I'm not saying that it is not being addressed, but there is a greater focus on the environmental aspects when we talk about the green buildings. The next is the climate responsive buildings. Now, these buildings respond to the climate constraints through their design and construction. However, aim of these buildings is to not only respond climatically, but fortunately, many of the climate responsive buildings traditionally qualify to be called as the sustainable buildings because they do not only respond to the climatic conditions, but they also use the best of the materials, the best of the available resources, and also the ones which are renewable, which are easily renewed in nature. However, the main aim of the building is to respond to the climate of the space. And next, I'll just take the example in the next slide. Next is the ecological building. Now, these buildings are the structures that are designed to create and sustain mutually beneficial relationships with all the elements of the local ecology. So the building's local ecology or the environment is made of particular physical, biological elements and an interaction between them. I'll just take the example. So this is the example that we see is for the climate responsive building, a Hawa Mahal. It is a apt example, I would say. It is, although it is extremely resource intensive because it uses stone extensively, but creates absolute absolutely comfortable environment indoors because it responds to the climate. So that so what is the main aim of the building? It is mainly to create the climate responsive and thermally comfortable, and that is why it is a perfect example for the climate responsive building. Now, this one, if you see, this is also a sustainable building and a completely ecological building. it is the entire building, this entire setup emerges within the surrounding. It consumes the material which is conveniently available, the surrounding materials, they use it. It does not affect the ecology around these buildings. And such buildings only enhance the ecology around, and they do not disturb the ecology around this. Now, when we talk about the green buildings, there are lots of buildings rating systems that has come up. The most popular concept we would say is the green building. It is the building which reuses less of water, optimizes energy efficiency, conserves natural resources, generates less waste, and provides healthier spaces for the occupants as compared to the conventional building. Now, out of all the concepts which are related to sustainable architecture, green building concept has become very popular for a few reasons. One, that green building rating systems have come into place, and because of these rating systems we can assess the performance of the building. We know where the building stands, so there is a benchmark, there is a comparison between building to building, and we know what performs and what doesn't. In this way people can monitor and hence get motivated too. This has actually driven the market because these rating systems are the most popular concept in the sustainable architecture domain. We hear about green buildings and the rating system almost every day. The fundamental reason, I repeat again, the measurement is possible through the assessment tools. Various tools are available. Broadly, they are the various parameters under which they are categorized. All the measurement tools are the sustainable site, the water efficiency, the energy, the atmosphere, the material, the resources, the indoor air quality, awareness and education. Even that is covered under the green rating system, and innovation and design with location and linkages. So these parameters in different rating systems are being given different weightages. In some or the other, in some of the rating system, the material is given more weightage, in some energy is given more weightage, and in some cases awareness and education is kind of not present, but although they are being adopted at a greater level. So these different parameters of assessment are present in different rating systems for different weightages. We go to each one of these rating systems. We can compare each of the rating systems, and then on the parameters that are described within it, the buildings can be classified under which star rated, or whether it's platinum rated, 1 star, 2 star, 3 star rated. So when we are talking about the green buildings, we should also make an account of the benefits of the green buildings. When the green buildings actually they reduce the energy to almost 24 to 50%, the carbon dioxide emissions to almost 33 to 40%, the water usage to almost 40%, and the solid waste usage to almost 70%. Along with these benefits, there are individual benefits, there are regional benefits, and there are global benefits. At an individual level, it reduces the bills of the energy, the water, the air quality, the maintenance, which is required. And at a regional level, when we talk about it, it gives a better water system, groundwater recharge. When we are looking at the vegetation, we are looking at the ecology. Then we are looking at the waste management. All these get a great benefit. And at a global level, when we are looking at the benefits like global warming, getting away from the global warming, then climate change, we are looking at the forest protection, on all these benefits are there at the global level. So the green buildings come with a lot of environmental, economic, social benefits through the characteristics and also aims which we have set for the green buildings. We will just make a quick comparison between a green building, this is a green building, and a sustainable building. A green rated building, both are green, but green rated building and a sustainable building. If we look at the sustainable building, we often, these two concepts, they are a bit contradictory opinions on what the sustainable building and green building implies. Now, green building often looks at the environmental dimensions, while the sustainable building looks at the 3 dimensions in an equal capacity. However, when we go on to monitor it, as I mentioned initially, when we go on to monitor it, that becomes difficult. The environmental aspects, when we need to measure it, that becomes a little difficult. They are easiest to monitor in the rated building. For example, if we say there is a sense of belongingness to the building. So how do we measure it? We cannot measure it. So those things also get attached to a sustainable building. Now, it is often difficult to quantify, and hence we do not have the benchmarking or the rating system which for that kind of a aspect of a sustainable architecture, and as we have for the green buildings. So when I repeatedly talk about this difference between the green and the sustainable, let me take up an example which is a certified green building and highly acclaimed green building versus a sustainable building. So the example that I've taken up is a Suzlon One Earth example. So this campus of Suzlon One Earth is an platinum rated, extremely proclaimed building, 100% where the entire 100% energy is renewable energy. Since Suzlon itself being a company which is involved in the renewable energy, they have their entire campus, which is 100% renewable energy. They have installed windmills, they have added solar photovoltaic to generate the entire electricity usage within the campus, on the campus, and part of it outside the campus. They have all these on-site, off-site wind turbines, photovoltaics, which cater to their needs. They have hybrid solar chargers, which interchange between the mode of renewable energy from wind to solar, depending upon the availability. Then the entire building is a net zero campus. It does not draw any energy from the grid because it generates 100% of their energy on site or off site, but it is of their own. This is the production side. However, at the demand side, they have managed very good systems. The first being the correct orientation of the building. So the building has been oriented in such a way that all their work spaces are daylit almost throughout the day without any glare or direct sun penetrating into the interiors. The second important is the use of materials, the material that are used. This particular building was constructed on the hillside, and the material was taken up, all the material was excavated from the area surrounding that site itself. So even in case of material, it was a perfect example. Then the perfectly oriented, the lighting was perfect, the skylights, the windows are at a high level, the skylights are provided, the workspaces are well lit. And the landscape, they are using the native plants for the landscaping. And of course, the native plants require less of maintenance, less of water. And next one is the water management. They recycle the entire 100% wastewater of the site, and the same water is fed back into the system for the users like flushing, and they have the dual piping system. All the latest technologies are included into it. The water system is a closed loop system, so there is no wastage. And next we move on to the this is a perfect example of a green rated building. Now when we compare this with this building, this is a primary school in Burkina Faso. This is a primary school which was built for local children, for the community, by the community themselves. Now, for the construction, they have used compressed earth blocks. These were made with the help of the community participation itself. The parents of these children came together to make these bricks. The stone was locally available. The climate condition was very harsh, and the school was constructed for the underprivileged community which was living around. So the construction material which was used was from the surrounding materials and locally available material, which has very less embodied energy. They are made out of the materials which were, you can see the double roof system that they have adopted here. A brick slab roof, it has a double roof on top of it, which helps to keep the indoor environment comfortable, as it takes away all the heat. This cavity takes away all the heat which is accumulated which is gained from the solar radiation, since it has a very harsh climate. It is the thermal comfort was the main criteria. The second roof was implanted on it. The mass of the roof helps to keep the temperature low. The entire building was actually proposed as an extension, school extension, and it served the community which was living around. The unique design of the buildings, of the windows, the unique design of the windows to ensure that the indoors are daylit, no artificial lighting system is there. There is no fan, no electricity as such over there. So it is naturally ventilated without any mechanical system, based upon the thermal comfort needs of the community. And it provides a comfortable thermal environment indoor. Since it was a very dry region, it doesn't have many trees or forest belt. So all the material that was used, it was used judiciously and not in a very huge quantity. The main material was the earth. And this is for roof, where the indoor beautiful aesthetics have been achieved. There was one more pic. It's missing out here. There was a beautiful indoor aesthetic arrangement has been achieved without spending at all, I would say at all, in the materials, by engaging the people around, by involving the people in designing and constructing the material. So that is the basic difference between the sustainable building and a green building. So I think it is quite evident out here, where the green buildings are focusing only on the environmental aspects, while a sustainable building, we are focusing not just the environment, but it is human-centric. It is by the people and for the people, and designed completely for a community. And for these human beings, we create architecture which is environmentally responsible. Another thing which we can see here is the affordability, the economic affordability. Now, this office, Suzlon One Earth, is an outstanding as far as environmental aspects are concerned, but it may not be affordable, affordable in terms of the model of affordability. But this is out and out affordable. since there is no cost which is going into it. So we very clearly know when we are talking about sustainable architecture and we are talking about green buildings, they are two synonymous, very close, but distinct terminologies and distinct philosophies. And both lead to a journey towards the net zero buildings. So that's all from my end. Am I there?
Yes, ma'am, you are. Thank you so much for your presentation. And I would really like to say that this was a very informative presentation, very informative. And Architect Lori educated us on different organizations which are associated with climate change and certain facts about, I think nobody knew about that fact that only 5 to 7% reduction in emission, which was there in the pandemic. And she also explained certain measures and concept by how we can reduce carbon footprint, and we have to start at as early as possible. And because now we have the opportunities, we have the measures, we have the time. And now with this, she also educated us on green building certifications, benefits of the same, and we actually have to, start building green, sustainable, which is human-centric as yes, exactly, human-centric. So thank you so much, ma'am. Thank you for your presentation. Moving on. Energy is essential to life and all living organisms. So energy efficiency is good for us, for the air we breathe, for the water we drink, and for the community we live in. So saving energy reduces air, water pollution, and conserves all our natural resources, which in turn we can create a healthier living environment for the people everywhere. So now I request everyone in the audience to kindly fill in the feedback form and the question in the chat box if you have any. We will be answering your questions. I would even like to add that we are even live on YouTube, and the audience can join us from that platform as well. Our next session is on energy efficient architecture. For this, I would like to invite architect Surinder Baga from Sakar Foundation, Chandigarh. He established his architectural organization, Sakar Foundation, in Chandigarh in 1984. Worked as a chairman of IIA Chandigarh Punjab chapter, chairman of IIA Publication Board, and editor of Journal of Indian Institute of Architects, and he was even nominated as councillor in Chandigarh Municipal Corporation. Recently, he has been appointed as the head of Chandigarh subchapter of FSAI and chairman of GEM Chandigarh chapter. He has co-authored 3 books, namely Modern Architecture in India, Post-Independence Perspective, New Indian Homes, Le Corbusier and P.D. Johnneray, Footprints on the Sands of Indian Architecture. He's even received several awards for his marvelous work. So he will be addressing our audience now. Over to you, Baga sir. We have architect Surinder Baga.
Thank you, Ramneek. Thank you.
You're welcome, sir.
Thank you, Ramneek. We are running slightly behind the schedule, so I will be rushing through my presentation now. My topic is energy efficient architecture. So I will quote that there are many verses and shlokas in all the religious scriptures of India highlighting the importance of saving the Mother Earth. This one is in Holy Quran, the Hindu scriptures. It highlights the importance of a tree in our lives. In the Holy Guru Granth Sahib, there are many shlokas which are laying stress on saving the Mother Earth. Likewise, Quran में भी बहुत सारी ऐसी आयत included हैं which are advising the mankind to save environment. Similar are the verses in Bible too. When we talk about sustainable architecture, it means taking less from earth and giving more to people. We all know that buildings consume about 48% of the world's energy. And if we look at the historic overview of India, this is the picture of Mohenjo-daro township. when this was designed in the year 2600 BC, our forefathers have taken care of the wind direction, the local materials, the drainage system. This was the drainage system, which was well planned and laid out there. Look at how many years back India was so advanced. And in 1156, these Havelis were made in the sand dunes of Jaisalmer. Look at the selection of materials. Look, the local materials are used, self-shading facades, small windows, and they are properly protected. And during the Mughal period, architecture was one of the best in India because they have a proper sense of utilizing water judiciously, and proper landscape was done, and the architecture was quite suitable to the Indian climatic conditions. In the down south, in the Jahangir Mahal Palace in Orcha, you can see this was a courtyard planning and thick walls, and there are projections to suit the local climatic conditions. Over the years, even during the British Raj, when Parliament was made and New Delhi was created, care was taken to design buildings to suit the climate of New Delhi. When Chandigarh was built, the same thing was done by Corbusier. But in the middle of 90s, India got a trend that we have to make glass boxes, like this is the PEDA Bhavan. It is a very beautiful building, very sensibly designed by a very good architect from Chandigarh. What happened is, when this building was 80% built, the architect was forced कि इसके ऊपर glass लगाओ so that it looks like a Gurgaon building. The concerned bureaucrat forced the architect कि I want glass all around. I don't want a traditional building like this, which was originally planned. So ultimately, they transferred the architect, and this glass cladding was done, and the facade was changed. The result is that this building works like a furnace. Whatever the amount of air conditioning we use there, but it cannot be comfortable. And when we talk about what should be the approach to design the energy efficient buildings, we all know that buildings consume electricity in heating, cooling, lighting, and water heating, etc. And the energy efficient building is one when we design certain features and we plan certain things to reduce the consumption of electricity. As Kangaraj sir has said, India is divided into various climatic zones. There are 5 zones, and one is the composite climate region in which Punjab falls. When we design buildings in a composite region, that there are fixed parameters, the design strategies. We have to resist heat gain in summer and resist heat loss in winter. We have to promote heat loss in summers and in monsoons. I'm going a bit fast because we are running behind schedule. This is the church which we designed in Chandigarh. It was rated one of the best building by TERI and by Government of India. In this building, we have used cavity wall, and even you can see in this picture, the top vault is painted white to reflect light, and the exterior is treated with a light color so that the sun heat can be reflected back. Windows are small. You can see this, there is a cavity wall all around in the plan, and there's no artificial light requirement inside the building. And likewise, we designed this church in Chandigarh in long back, and this is the western facade. On the western elevation, we opt not to put many windows because sun heat is too much in the evenings. So what we have done in this building is that windows are very small, or they are hidden. There's a skylight or something like this. The result is that this building works much better climatically, and it is very comfortable building when we get reports from our users. Similarly, this is another building which is facing the western direction. when we were designing this, we decided to put all the toilets on the front side because this is the western side. When the western sun falls on it, only toilets get heated up and the heat is not transmitted in the dormitories where children are staying. You can see small, all the windows are properly protected, thick walls and terraces are there. Then we designed this Yadavindra Public School in Mohali. In this school, we have taken care of how to protect the windows, and this architectural vocabulary was borrowed from the original school, which is designed by J.K. Chaudhary, a very famous architect who designed the Punjab University campus and IIT New Delhi. So we opted to have style of architecture which will fit into the existing campus. And in the interior of this, you can see this is a corridor running, and we have cutouts on the either side. These cutouts are facilitating air movement, and we bring in a lot of light from the top skylights. And these cutouts are also shielding the interiors of classrooms from the noise which is emanating from this corridor when the children walk there. Baptist School Chandigarh is another Christian school. In this school, we have tried to protect our glazings with a combination of horizontal and vertical louvers, and toilets are again brought to the western end. We introduced courtyard planning. This is the model of the same school. You know, courtyard planning is considered to be very traditional, but we opted to have this courtyard planning in a modern building because it works in Indian climate. Likewise, we designed a convention center in New Delhi for the Ministry of Agriculture, and we got the first prize because in this project, the brief was we are not supposed to cut any tree and we are supposed to make it energy efficient. You can see this, the entire roof of this convention center is made with the solar panels. In addition to that, many other features like rainwater harvesting and so on, solar lights, they are introduced in this project. Lopo is a small village in the Moga district in Punjab. I got a friend there. He wanted to build a very, very small library there. And we both decided to have something new there. What we did is this library is facing north and south, and the windows are kept after the height of the book racks, and book racks are placed along the external walls because the book rack itself is working as a insulation material. And on the top of the terrace, we put a cooling tower, and that cooling tower cools the air, and that cooled air is brought down through the decks. And you can see these small windows which are deeply recessed, and they're facing north and south. And the eastern and western side, you can see we have a cavity wall or the toilets or the staircase block. The resultant is the building works even without AC and even without fans. Then we got a chance to design a very big university campus in Punjab. It's about 50 acres, and the client wanted that all his buildings should be facing the main road because that will give more impact to the aesthetics of the university campus. We insisted that we should follow the right orientation, which is followed in the Punjab University campus. That is, the longer sides are facing north and south. Ultimately, we convinced our client, and these are the buildings which are made. These are academic blocks, about 8-story high blocks. All blocks are facing north and south, which is the best orientation. Then next climatic zone is hot and dry. And in this zone, when we design buildings, this is the design strategy. We have to resist heat gain and we have to promote heat loss. And we happen to design a very massive township in Jaipur for the Indian military. We made 800 houses for them. And here also the design strategy was that we have to make the houses facing north and south. So 99% of the building blocks are facing north and south, and that was the only right orientation in a desert region. And we opted for light colors, and all the windows are properly shaded and balconies are there, and self-shading facades are there. Trees are not allowed to cut. So that was the hot and dry region. And now coming to the next region, which is warm and humid, we happen to design certain youth hostels in West Bengal, Odisha, and Assam. And this is the coastal belt, and we get a lot of suffocation in a warm and humid region. My architect friends and engineer friends are knowing it, that when we design buildings in a humid region, we need to promote a lot of ventilation. So what we did is, we got a chance to design a youth hostel in Burdwan in West Bengal. The site was very remote. You hardly get any proper electricity when it was made there. So it was the building itself was located in a very remote area. What we did is that dormitories are provided with ventilation from 6 openings. These 6 openings, when they are opened up, they get enough of breeze and enough of ventilation. The result is that even if there is no electricity, one can stay there. Because it's a humid climate, buildings get blackened. Even the color scheme was decided accordingly. The windows are shielded with boxes, the concrete boxes. You can see, because of the rainfall, we opted to have a box projection all along the window. And because rainwater pipes get choked, so we opted for rainwater supports. And another zone is a moderate zone, which is a small pocket near Pondicherry. Here the climate is comparatively less harsh, and architects can take liberty to design buildings which are to experiment a little more. This is the project of Bajaj Autos in Pune. Here, this project was done by my architect friend Rumi Shroff from Bombay. It's a beautiful building to my mind, because here you see the staggered slit windows are provided. The architect opted to have a white color scheme, the earth berms, and even the interiors, get enough skylights. Next zone is cold and cloudy region, which is Kashmir and parts of Himachal Pradesh. Here the design strategies are totally opposite. We have to resist heat loss, and we have to promote heat gain. That is the design mantra. And we got a chance to design a composite regional center in Kashmir. And in the salient feature of this project is we have tapered this slope at a particular angle, so that, when there is a snow, it falls automatically, and no mechanical or physical cleaning is required to clean the snow, which is a very major problem in many of the buildings there. And in the end, before concluding, I will just give you some stray examples. This is the building in New Delhi, Indira Paryavaran Bhavan. It is claimed to be net zero building, where the entire roof is made of solar panels. You can see in this picture. Then another building in France, which is considered to be net positive building. The salient feature is that the entire building is clad with solar panels on a terrace and on elevations, on side elevations, and on all the sides. So the architects are claiming that this building will be net positive. And this is the building in Miami, where architects have tried to put wind turbines which are integrated into the building facade. This is India, Lonavala, near Bombay, designed by Charles Christopher. This is the longest wall in India, rather in the entire world, which is made of solar panels. And Glory ma'am has already shown one of the projects designed by him. He is a wonderful architect doing very good work in the field of energy conservation. And in West Bengal, this is a housing project done by West Bengal Housing Board. And this project, you can see the design is made in such a manner so that, the building design is integrated with the solar panel design. You see how they have fitted the solar panels in the roofing plan. Even waste bottles are being used to make walls. This is a slide showing that. Bamboo is a very useful material, and all sort of materials from scaffolding to boards to roofing sheets, all is available in bamboo now. And this particular school in Bangladesh got one of the highest award in architecture, which is Aga Khan Award. The first floor is made of bamboo, and you see how beautifully it is made. And the result is that this got the highest award in the world in architecture. Another slide of the same interior. A lot of research is going on in Auroville on the bamboo architecture, bamboo as a material. And this is a picture of that. This bamboo architecture, bamboo research center is promoting. And in Shanghai, in the year 2010, this pavilion was made in the International Expo, which is made of bamboo, because India produces a lot of bamboo. Already, India is among the top bracket in bamboo producing countries. You see the bamboo in the Shanghai pavilion. Architect Neelam Manjunath is doing great work in bamboo architecture. These are the pictures taken from her work. And the conclusion of my talk is that when we design buildings in India, we have to take care of the climatic conditions of the country, the habits of the people, the economy of the country, the local materials. And if we do so, we can be helpful in saving the Mother Earth. Thank you so much.
A very well presentation by architect Surinder Baga. So, sir, in his talk, briefed us on different climatic zones of India, and it is definitely advised that these buildings should be designed accordingly to the zones. The examples he gave in the presentations fit perfectly, as those were kept in mind, keeping the user and their comfort. Exactly. So, and even in his last slides, he gave many examples and techniques, which definitely shows that we have to make our architecture energy efficient. And now moving towards our last presentation of today's session on thermal comfort and strategies, I would like to invite engineer Vivek Mahajan, an ECBC expert. He is an engineer by profession, having over 18 years of industrial experience in the field of MEP, FP, and sustainability. Having experience in the US and India, his knowledge base is in healthcare, institutional, industrial, commercial sectors. And Vivek is also very well versed in the international codes and standards. Engineer Vivek enjoys to speak on energy efficiency, net zero strategies, and innovative design concepts for buildings, and similar to subjects to students, corporate offices, to awaken awareness for saving energy in the long term, for the long-term benefits. And today he would enlighten us on thermal comfort and strategies. We have engineer Vivek Mahajan with us. So over to you.
Hi, Ramneek. Hi, everyone. Ramneek, can you hear me? I just want
yes,
to confirm
I can.
that I'm
yes,
audible.
yes.
Thank you
yes,
so much,
audible.
Ramneek. Thank you so much, PEDA and Surinder, sir. I totally appreciate the kind of efforts the PEDA and the entire, the Sarkar Foundation is putting into looking into the energy efficiency, moving Punjab to the next level. So I just saw that it's already 4, so I'm talking between the time of the questions and answers. So I don't want to stretch too much and spoil the time where the people wants to actually answer the questions, raise the questions. So I'll just quickly go through the presentation.
An option of share screen, sir.
Can you just guide me that, how do I'm sharing
okay, so there's
screen.
an option, there's a green option which has share.
Yeah, I'm just putting it here, but I don't see my the files here.
Okay, so in your whatever more source, yeah, now we can see your screen. Definitely now,
All
yes.
right. Yeah. So
Okay.
I didn't realize like it has to be like an entire screen share. So,
GG, so it will
well,
be, yes.
so I'll just quickly go with the thermal comfort. I wanted to highlight like what is thermal comfort. Thermal comfort is basically the condition of the mind where we all feel, yes, it's excellent. We feel comfortable in the environment. So that's basically a layman language thermal comfort. Again, like we see like a thermal comfort, if we see the definition in terms of a technicality, it has a lot to do with the air, with the velocity of the air it is, with the temperatures that we are sitting in, the clothes we are wearing, the kind of like surroundings and the thermal environment, close to us. So I don't want to go so much in technically, and so I'll just try to bring a couple of information right from the stone man to the current scenario, how the thermal comfort is moving in the modern days. So let's go back to the thermal, the stone man, or we say like the ancient time. So our stone man used to stay in the shades during the daytime. They used to like hang around here and there. In the night, they used to stay closer to the the stones where the sun has completely given the thermal mass, the heat to the thermal mass, and it's basically radiating. So this is like one of the picture, like this is how the stone man started developing, trying to get the thermal comfort. फिर हम जब जाते हैं, then we see like how the thing happens when the stone man moves to the next level. He realized that only staying in just with the close to the stone will not help us out. We need to provide some sort of the building envelope, some sort of the proper covering so that we can protect ourselves from numerous things. So he created a kind of a chaja, he created a kind of a hut or something, and then he starts sitting in where he starts getting the thermal comfort in the spaces. Then he moved on, then he realized another picture, then he thought like, okay, let's make like a mud, the huts, the mud houses, and he started actually, building the entire enclosures, right? Bagasar said, you call like in the old times, the bamboos, or you say like, the whatever the muds and that we used to use. So this is the next example that was the people were start moving to the next level and trying to get the thermal comfort. Then the stone man realized, yeah, exactly, it's not helping us out, because when we close entirely the building envelope, it's not, the heat is building up, it becomes thermally uncomfortable. So he starts opening the windows or starts giving the openings. But again, like if you see that it gives like a air, it gives a ventilation, but at the same time, the sun is directly harsh and it's not giving any sort of a shading, and it adds on again the heat to the space, and thus provide again the uncomfortable situation. Then the human realize, let's do that. Let's build some sort of a insulation. Let's build some sort of, the proper roofs. Let's provide some sort of a shading devices. So humans started giving the shading devices. He understood, the humans realized like opening the windows, providing the right envelope, providing the proper shading we are talking about is completely making our buildings, making our occupants thermally comfortable. Now, what happens in the modern building? Now this is a modern man. So modern man realized like we completely are into the modern world where there's a lot of honking over the roads. So we can't go with just houses on the roads, but we need to have a proper building insulation, proper building, envelope, window close. But when we do that, what happens? The heat build up inside completely, and the human becomes thermally uncomfortable. And just to protect ourselves from this, fundamentally created, the surroundings, we end up putting our system. So the drawings are created by my child, who is a 10-year-old. So this is one of the presentation when I asked him to give me some help. So so this is the current scenario. If you look at in order to achieve the thermal comfort in the modern buildings, what we have done so far. We have put like chillers, we are putting a mechanical ventilation, we are putting like, air conditioning systems, and the ducting and all, so many massive things that are going on. So the intent for this entire thing to show is like, we have gone from a bare nothing to get a thermal comfort, to have like all modern systems, and all these modern systems are ending up adding up a lot of energy utilization into the systems. We all know that 50 to 75% of the energy in a building that goes to the active air conditioning of a particular building. So that's a fundamental, very important part. Like, how do we control, and how do we control and make our building energy efficient? Like exactly we have seen our previous presentations by architect Kangaraj, by Galori, Surinder sir, like how we have to do the different designs to achieve the building energy efficiency by either the passive design, better building envelope, better fundamental green building designs. So those are the important parameters. But again, if we look at it, how we make our HVAC system, because it is going to be there. Now HVAC system, everyone in their houses has the air conditioning installed. We can't even sit for a single minute in the peak summer in the car, because it's like a box chamber, and the ambient is like a 45 C. So technically we all turn on our ACs on. So it's a mandate now. Now the intent is how do we achieve the energy efficiency, and this is what I'm talking about, the active thermal comfort and strategies, that how we can make it like energy efficient. What are the efficiencies that we have to keep in mind, that we ensure our systems are not gone very energy consuming. So like architect Kangaraj rightly said, 3 modes of heat transfer: radiation, convection, and conduction. The conduction can be easily measured in the U values. Like the building skin, the roof glass wall, that gives our U values. So that's basically is counted for the conduction to the building. Then convection we can count in the molecular transference that happens. So the relevant terms that you probably see is the air changes, and or if we all are aware about that, how many air changes that happens in a space. CFM, cubic feet per minute. For example, if all of us see our even split systems or our window ACs, or any of the air conditioning system, we theoretically, ideal situation, we say like 400 CFM per ton. So 1 ton में 400 CFM होता है. This is what the convection correlates to. Then again, the radiation, easy term is like solar heat gain coefficient, which is the feature of the glass, because the glass is the primarily source where the heat transfer through the SIGC, or you call like a shading coefficient. So HVAC. HVAC, we have the heating. H stands for heating, V stands for ventilation, and AC stands for cooling, dehumidification, or heating systems. Technically in India, we don't use too much of heating, but yes, of course, in the winter dominant zones like Leh Ladakh, Kashmir, the Sikkim, and Uttarakhand, Himachal, they do require the heating, and then of course the humidification as well. So now HVAC systems, we all know we have what kind of systems that are available. We have window air conditioning that most of us have at one point of the time installed at our homes. Split air conditioners and other systems. So these are normally called a unitary air conditioner. So why they called a unitary air conditioner? Because this is like a single zone, and these are like, it's just like a one body, one system, which is like having like indoor and the outdoor, and it's a self-contained in case of the Windows AC. So if you look at the diagram, one side is the condenser, one side is the evaporator. So where is the evaporator? जो हमारे घरों के split system indoor unit लगता है, that is the evaporator side, because that takes all the heat from the space and throw this back to the outside ambient. That's called where we reject the heat to the atmosphere. That's called a condenser. So condenser side. So this is a typical, the graph, the typical cycle that keeps going in the air conditioning. So some basic formulas that runs. So if technically anybody can see there, whenever they buy the air conditioning system, 1 ton is equivalent to 12,000 BTUs, which means 1 ton जो है 12,000 BTUs British thermal units heat इतनी वो निकालता है उस space में. And this could be correlates very easily to the, you can easily find out by calculating the U values of the glass orientation. And it's there are a few very easy what it says, the simple softwares available online even to find out. Now what thing is important is in terms of whenever we select the air conditioning, it's important we choose the coefficient of performance. So why it is important? Because 1 ton of air conditioning, if you think about 1 ton का air conditioning आज से 10 साल पहले power consume करता था equivalent to 2 kilowatt per ton. So this is what it used to do. Now in today's time, because of this all codal development, all energy efficiency that we are talking about, all B initiatives that we are talking about, we are able to achieve equivalent to 1.1, 1.2 kilowatt per ton. So that's an important aspect. Like whenever we use, so the systems that we see in the market, the B 3-star, B 5-star, so that means the system is inefficient, but 3-star or 5-star becomes irrelevant when you go lower the temperature beyond 22, 21 C. Because when you do a 21, 20 C, the efficiency of the systems is really not making any sense. So this is a broad, the figures for the unitary or any sort of like us finding out the kilowatt per ton. Another few basic formulas to find out how much air changes, how much CFM that you require for your room, for a natural ventilation, natural ventilated spaces or mechanical ventilated. We can't solve an example here. So I guess I'll leave the presentation here, and people can solve. There are fairly easy calculation. This tells an example. If you have a room of 14 feet, in the length 12 feet wide and the height of 12, how much total CFM that we need, and we can easily correlate. Go back to the NBC 2016. We can pull out the chapter for the ventilation, find out 6 to 8 changes, whatever we require, and this is the simple formula. So the simple formula gives us the total CFM. Once you get the CFM, 1 CFM cubic feet per minute, one can easily go back to the market and see like how much is the total tonnage equivalent that we are looking at. So this is the easy way. So so we talked about the unitary equipment, then we talk about the VRV system, जो हमारे VRV system होते हैं, which is a variable refrigerant volume or variable refrigerant flow systems. So these are the systems very commonly used in the modern buildings, ranging from that requires total tonnage of 100 to 300 tons, because those are like very easy to install, and they are very efficient. Actually, the benefit is like a outdoor unit. Many of the engineers from the current attendees might have done the installation and might have been doing designing these systems. So these are fairly available in the market and aggressively. So they are having a very high coefficient of performance and the efficiencies. So these are again a water cooled and the air cooled. Air cooled being dependent on the ambient air, and the water cooled depend upon, if we have a water, it's definitely having a very high energy efficiency because the heat rejection happens through the water. The next is the water cooled chiller, which is commonly being used in the the centralized building like the hospitals, like the malls. Why these systems being utilized in the the malls and the hospitals, so the 5-star hotels? Because these are energy efficient. They have like a electrical consumption of equivalent 1 kilowatt per ton. So think about like unitary equipment air conditioner that we talked about, window air conditioner or the split air conditioner. From 1 ton we reached to the almost like from 2 ton we reached about like a 1 ton 1 kilowatt per ton consumption. So that these are like highly energy efficient. The only thing is they comes up with a very high capital cost. So air-cooled chiller is another that you can see sitting on the terraces of the building. These are again based on the the ambient, that they reject the heat to the ambient. But again, they are utilized on in the similar buildings, commercial buildings. They are again energy efficient, having your load of 1.2, 1.25 kilowatt per ton. But it gets us the very good diversities of the building. Then again, this is again a central chiller plant that one can utilize and can achieve even less than 1 kilowatt per ton. So this is primarily we need to look at when we do active air conditioning, and we say like we need to install a high energy efficient systems. So now, as per the NBC or as per the ECBC, or we say like the Bureau of Energy Efficiency, we're talking about the ECBC or energy efficiency. The natural ventilation is there, which has to be met as per the NBC 2016 minimum equipment efficiencies. हर किसी equipment की एक minimum efficiency B ने ECBC ने define करी है. So it's our moral duty now that we try to see that our efficiencies are all meeting as per those requirements. Then we talk about controls, piping. These are all majorly being utilized in the commercial buildings of the large scale. The comfort system, there are some basic formulas that are given how you can find out the indoor operative temperatures, how we can achieve the thermal comfort by having the natural ventilation, and by doing the air conditioning, what are the set points that we can achieve. These are some sort of basic formulas that is already there. I'll just quickly go through the efficiencies. So we have straightforwardly, we are defining now as per the latest energy efficiency standards that any of the system that we are looking at, the minimum coefficient of performance for the VRV system should be 3.2 a minimum. But nowadays, to be honest, just because of these, the high stringent codes, there is a the competition between the makes, between the different VRV manufacturers. The efficiencies are even going beyond 3.6 and 4. So these are the good things that we are getting just because of this fundamentally setting up some sort of a norms. Again, there are few efficiencies of that we are defining for the unitary equipment, unitary split package, everything. So if you have an air conditioning of 10.5, one can easily select that it just have to be a B3 star rated. And if it is higher than 10.5, it's a simply like water cooled can be installed. Air cooled versus water cooled, we have given it straightforward here. तो हम लोग ये चूज कर सकते हैं. अगर आप घरों में स्प्लिट एसी लगाते हो बट वाटर कूल, तो it's neither possible and neither feasible. But yeah, the air cooled, now we are talking about that it should be 5 star. So when we say 5 star, it's definitely our energy efficiency or the energy consumption per ton is about a 1.2 kilowatt per ton. So आप एक कन्वेंशनल नॉन बी रेटेड स्प्लिट यूनिट में और B5 स्टार में जब आप कंपैरिजन और जब एनर्जी एफिशिएंसी देखते हैं तो एटलीस्ट यू आर सेविंग 0.3 to 0.5 किलोवाट पर टन. सो एक टन के पीछे अगर आपके घर में 3 टन का यूनिट लगा है तो टेक्निकली यू आर सेविंग 1.5 किलोवाट का 1.5 से 2 किलोवाट ऑफ एनर्जी एवरी आवर. एंड इफ योर बिल्डिंग रन्स, इफ योर टोटल सिस्टम रन्स फॉर नाइट आवर्स, the entire full night for 10 hours, think about like we can save we can save about like a 15 kilowatt hours. So this is a saving in the energy that we are having now. So a couple of another energy efficiencies that straightforwardly defined in the ECBC code that we can look at it. So yeah, so that's all, and stay comfortable and healthy, and this is what the next goal and the responsibilities that we are defining. And I hope like we all try to achieve at one point of the day with all of our efforts. Yeah, thank you so much, and thank you Ramneek and Surinder sir. That's all from my side.
Thank you so much, sir. So this was Engineer Vivek. He educated us on thermal comfort today in his session. Temperature where we neither feel warm or cold is what a thermal comfort, is. So now I really appreciate the caricatures Sir explained in his PPTs to actually explain the concept. For this, also, he educated us on building envelope, lighting, and insulation material orientation. These all are the factors that are actually going to help us achieve the thermal comfort. The timeline to explain the concept was commendable, from an early man to modern man, and the change in techniques and technologies we've seen in the times. And the systems he even explained to achieve thermal comfort in our buildings. Thank you so much, sir. I request our audience to fill the feedback form, which is available in the chat box. And this is going to help us for our future webinars too. I really appreciate if you fill the feedback forms. And now, without taking much time, I would like to invite our next speaker, Dr. Aarti Grover from SP Delhi, to give the concluding remark. We have
Hello.
Dr. Aarti. Yes, ma'am.
Can you hear me now?
Yes, ma'am. Yes, we can.
All right. Okay, so good evening, everyone in the room. I see a lot of people still sitting and enjoying the talks that were happening throughout the afternoon. It is with great pride and pleasure that I take the opportunity to conclude a very, very informative and well-structured seminar on energy efficiency. And I would like to congratulate, of course, PEDA and BEE for this wonderful initiative to create awareness about energy conservation. What I feel is that PEDA is doing a great deal in, and they're leaving actually no stones unturned to make sure that the application and dissemination of the knowledge in this field is done at the best, which is a great endeavor, I believe. And then the other thing that I'm seeing these days are happening is large number of seminars, workshops, which are being conducted in even the small towns of Punjab and Haryana. And I see, especially in Punjab, I have attended because I'm from the place, I can really relate to the situations in Punjab. We have so many architects, and this sort of guidance is definitely going to help them a great deal in improving the kind of architecture we do, incorporating the way how energy efficiency can actually become a very important part of architecture. And then it helps all the stakeholders, the students, the professionals, in a very specific way. Everybody has a different takeaway from these kind of talks and seminars, which is a great endeavor. I have to congratulate them, big deal. Then now regarding today's work, what we have seen, I've been actually asked to briefly conclude on to all the four things that on the four talks that we've heard today. Of course, Ramneek has done it in a greater depth, but I'll probably in a line or two summarize what we've heard today and what we have learned today. So the first thing that I have to say is that listening to all the speakers who probably belong to Punjab, I must say that it ensures that our Indian scholars have a lot of things to share. They have a lot of knowledge base, only that we have to tap it in the right direction. And that is what exactly this seminar has helped us to do. And the state agencies are doing their best to create awareness in the domain of energy sustenance and energy efficiency, which is again a very, very congratulable thing. The first talk by Ganeshan, by Kanagraj Ganeshan, it was very, very enlightening because, he is a very well-known name in ECBC circles. And he very efficiently explained the intricacies of designing building envelope to save energy. That was a very, very informative presentation. And I think the best presentation to set the tone of today's webinar. Second presentation was on sustainable design concepts by Glory, and she clearly demonstrated how green buildings can help in reducing carbon footprints. When I was listening to Glory, I also heard she talked about the role of trees in modification of microclimate. And since I am trained as a landscape architect, and that is my profession, so I cannot actually stop myself but adding two lines here, which is that landscape, and appropriate, a good landscape technique and a good landscape design and an appropriate site planning has a major role in reducing stresses with respect to energy consumption. If the location, context, and orientation of the building blocks are suitably organized in a site, the energy levels can actually be reduced a great deal. And that is, so landscape architecture, the methods are passive, and yet the effect is high. So they are passive yet effective. And also they lead to less use of mechanical support, which we need generally to do air conditioning and all that. So I think climate responsive architecture is definitely the way forward. And buildings which belong to the region, which are regional, which are local, in terms of form and material, both are livable, are the only buildings that are livable and successful. Others will need, of course, a lot of help from mechanical ways and means, which the local buildings will not, of course, require. So vernacular and local needs to be given impetus. That's one thing which Glory's presentation actually reminded me of. And the third presentation was by our dearest Surinder Bagaji, and he spoke on energy efficient architecture, so appropriate from an architect of his stature. He shared the practical tips on how to design buildings to suit different climatic zones of India. Again, I mean, his stature is such that even to comment on his work is yet, since I have to do it, the highlight of his presentation was the beginning part, which connected technology with culture and religion. I really appreciated the way how he connected it with the religions of Indian subcontinent, and then many examples and state-of-the-art practices, reassuring that climate responsive architecture is extremely important to practice in today's context. We are all doing different forms of architecture, different natures of work we are doing. All these things have to go and connect to becoming climate responsive. Otherwise, the basic need of architecture probably will not get fulfilled. Kudos to architect Bagaji. Great presentation again. The last, but not, of course, the least, was engineer Vivek Mahajan. And when I say engineer specifically, I'm sure, Mr. Mahajan, your son is on the way of becoming an architect. If you are an engineer, at least you are getting a son. You've got a son who is becoming an architect. His sketches told me that. And the presentation was on thermal comfort and strategies. And he talked about the evolution and lineage of this concept, which again was a good, it found place in the whole scheme of presentations. And then, of course, he talked about some quantification hints, which I think is a good takeaway. People who really want to quantify and empirically find how different levels of, air conditioning and all these can be solved. Of course, people can go into these details, and he is there to refer to, of course. So to conclude, I think systemic thinking needs to be encouraged in this domain, by which I mean that setting the processes, setting the systems and networks up for change. We've had, finally, I'll just congratulate and tell you that we've had a very enlightening and a knowledge-filled afternoon. Presentations by the speakers will definitely become a great resource material to reckon back to while designing our built environments. And on behalf of all of us, the speakers, please accept our heartiest congratulations and gratitude. And a big, big thank you to PEDA, BEE, and Sakar Foundation for bringing this webinar on and inviting us all to be a part of this great event. Thank you so much.
Thank you so much, Architect Dr. Aarti Grover. We are really delighted to have you here. And thank you for giving the concluding remarks. So ladies and gentlemen, we really appreciate you being with us, as this was the last session of our week-long webinar on energy conservation and energy efficiency. We really appreciate your support for helping us to make this event a great one and a huge success. And now I would like to invite Architect Dinesh Bhagat to present a vote of thanks to all our attendees and panelists. Nish Bhagat sir is a lecturer, Department of Technical Education, Punjab, and currently posted as Government Polytechnic College for Girls, Ladawali Road, Jalandhar. He has a rich professional experience of more than 25 years. He is currently Joint Secretary, IIA Punjab Chapter, and former 2 terms IIA Chairman of IIA Jalandhar team. Over to you, sir.
Thank you. Good evening. It's my pleasure to propose a vote of thanks for the contribution of each and everyone having made this webinar a memorable event. We would like to express deep gratitude to Punjab Energy Development Agency and BEE for giving us the opportunity to meet and exchange knowledge. Special thanks to all officials from PEDA and for their valuable support. We would like to convey thanks to architect Guneet Khurana from Amritsar for his welcome note and architect Dr. Aarti Garover from SPA New Delhi for her introductory address and her concluding remarks. We are also thankful to expert speakers, architect Kanakraj, architect Surinder Baga, architect Glory, and architect and engineer Vivek Mahajan for their nice presentations. We are grateful to the officers and staff of Department of Punjab, Mandi Board, Health System Corporation, Department of Health, Family Welfare, Department of Science and Technology and Environment, Department of Tourism and Culture Affairs, Punjab State Council of Science and Technology for attending this program, and Sakar Foundation Chandigarh for ably conducting this program. We are grateful to the office bearers of IIA Punjab and IIA Chandigarh chapter for supporting this program. Our special thanks are due to all of you for spending your valuable time for our sake. Thank you very much indeed, all of you. In last, I would like to thank Ms. Ramneek for her wonderful comparing for this webinar. Today is the last concluding webinar in 7 webinars in a row, and it was very difficult work indeed. Many friends have contributed to make it a series a great success. I would like to name few of them: architect Sanjay Goyal, architect Sekho Sir, architect Gitanjali Kapoor, architect Akanksha, architect Ravi Mahajan, architect Chahat Kalra, architect PPS Aluwalia ji, architect Sarika, Professor Pankaj Chopra, architect Rupendra Ahuja, then Mr. Jaspreet Barad, and architect Kiranjot Kaur. Our deep gratitude is due to all media personalities who have supported us wholeheartedly for the said program. Thank you very much.
Thank you so much, sir. So now we come to the end of our today's event. I would like to tell the attendees and the audience that we have a feedback form in the chat box and the portal will be open for another 10 minutes. So kindly please fill that feedback form. It will be a really great help to us. With this note, we come to the end of today's event. I would really like to congratulate PEDA, BEE, and Sakar Foundation Chandigarh for letting us encounter this very informative event on energy conservation. I would like to thank all our eminent speakers in these 7 days who have been there with us, like our support system and a kind audience for being here with us. In the end, I would like to thank all of them to help us make this event a success. And I really hope you have a remarkable day ahead. Thank you so much, everybody. Thank you so much. I would like to add again that the portal for the feedback form is open in the chat box. I would request the audience to fill the form. It'll be a great help to us for our future webinars. It has 10 to 12 questions in a yes or no format, which is going to take hardly 2 to 3 minutes. So please, it will be a great help if you fill the feedback form. Thank you so much, everybody. Hope you have a great day ahead.